Not really, no. A little bit. Alright, so today we're going to be doing 11.2, which is solving real-world problems involving rational equations. So first one we're going to look at, we're going to logic our way through it here. We're writing out a lot of rates and stuff. There's a lot of geometry setting up like you're doing geometry. You'll see. So it says Jason uses 20 gallons of gas to travel 400 miles. If Jason currently has 7 gallons of gas in his car, how much gas is needed to travel 200 miles? So, it doesn't say how much more gas he needs. It just says how much gas he needs. So it doesn't really matter that he already has 7 gallons in his car. No, because we're not worrying about how much more he needs. We just need to know the total amount of gas thank you, that he needs. So, I'm going to set up my proportion. Okay, miles, okay, per gallon. Okay, miles per gallon. You could have done gallons per mile. Okay. So the car can go 400 miles in 20 gallons of gas. Everybody understand that rate proportion? Okay. So, if it can go 400 miles for every 20 gallons, we want to figure out how many gallons it takes to go 200 miles. So, since I don't know, I'm going to call it what? X. Now, when you get here, we have something called cross multiplication. So, you have two options here. You can either multiply both sides by 20, okay, and then multiply both sides by x, but here's a little trick. If two fractions equal each other, and there's an equal sign between them, this only works if it's an equal sign. Does everybody hear that? Only equal sign. You can do something called cross multiplication, okay? And that's where you multiply the diagonals and set them equal to each other. So we get 400x is equal to 4,000. We then just solve it, and we get x equals what? 10 gallons. So it's going to take him 10 gallons of gas to travel the distance he needs to travel. So how much more gas does he need to put in his car? 3 gallons. So had the question asked, the next question might be, how much more gas does he need to get? They might say 3 gallons. But overall, the question that was asked, the answer would be 10 gallons. Okay? All right. You guys ready for the next question? Okay. So it says, Mary likes to travel to the next town to see the state fair. When she leaves her house, she can take one of two routes, the highway, the interstate. Mary averages 30 miles per hour when she drives on the highway, and she averages 50 miles per hour when she takes the interstate. Both routes are the same length, so distance is the same, and she saves 2 hours by driving the interstate. How far away is the state fair? So this right here is a formula. Its distance is equal to rate times time. In this case, rate is like speed. Okay, so rate acts as speed. So I just want to make sure you're aware of that. So when I do problems like this, I personally like to make a chart because I just think it's easier and more concise way to kind of get my information out there to myself. Okay, so I'm going to create a chart, and this chart always works for these types of problems. Anything where distance equals rate times time, you can use a little chart like this. So I'm drawing myself a chart, and then what I'm going to do is I'm going to label the values here. So distance, and it doesn't matter what order you put them in, I just like to keep it in the same order as the formula. So this is speed, remember rate and speed are the same thing, and then we have time. And then here are going to be the two different scenarios. So she can either take the highway, or she can take what? The interstate. So now we're going to fill in what we know about the boxes. So what is her average speed when she's on the highway? 30. What is her average speed when she's on the interstate? Good. Now, we don't know how long it takes, but we do know that it takes, let's say if we're going to do call time t here, so we know that it's going to take some amount of time to drive on the highway, but the interstate takes 2 hours less than the highway. So how could I represent the interstate's time? Good. Now if you look at this formula here, it says distance is equal to rate times time. So how could we represent distance? 30t, the product of speed and time. And then how could we represent the interstate distance?
50t.
Good. Like that. Does everybody see how we got all those values in the box? That just helps me keep it organized and I know what everything is. So then from here, it tells me some more information. It says both routes are the same length. What's another word for length? Distance. So these two distances are equal. So what can I do with them mathematically? Set them equal to each other. And then you can just solve it. So we get negative 20t equals negative 100, which means t equals what?
5.
Good. 5 hours, because it's in hours. But the question didn't ask about how long it took. The question asked how far away is the state fair. So far away, which one of these represents that? Distance. How can we now find the distance? Plug in 5 for t and we get 150 miles. Now, would it matter if I had chosen to instead plug it into this formula? No, because they're what? The same distance. So does anybody have any questions about that? Do you understand the concepts behind everything? Okay. So this one says, a local textile mill has a vat that can be filled with hot tar from an inlet pipeline in 60 minutes. So what they're saying is we can fill one vat every 60 minutes. That's what we call our rate. Okay, one vat every 60 minutes with that inlet pipeline. Okay, so this is the inlet one. We also have an outlet pipeline. But if you read carefully, the outlet pipeline completely drains a full vat. Drains a full vat. So if it's draining it, the rate's going to be what? Negative. So it's going to be negative 1 vat for every 80 minutes. Okay, it's negative because it's draining it. If both pipes are left open, how long would it take to completely fill an empty vat? So what we're trying to figure out is we have one vat, and we want to figure out how long it would take to fill that vat. So x minutes to fill the vat, right? That's going to be our rate that we're finding. So we know that if these two things are happening simultaneously, it's going to be equal to this, right? Simultaneously means some of it's going in, some of it's going out. So what we're going to do is we're going to basically add them together. 1 over 60 plus a negative 1 over 80 is equal to 1 over x. So, do everybody understand why it's subtraction? Okay. Now here's the good thing. It's going out slower than it's coming in, so eventually it will fill up, right? Because of that. So what we're going to have to do is we're going to have to find a common denominator over here. Okay, so there's really two ways you can do it. You can either find a common denominator over here or for the entire thing. So whatever you guys feel more comfortable with. Let's go ahead and find a common denominator for the whole thing. So what's a common denominator between 60 and 80?
240.
240. So 240, but then in addition I need it to have an x. So my LCD for the whole thing would be 240x. Okay, so this is going to get multiplied top and bottom by 4x to get me to 240x, right? This one's going to have to be multiplied by 3x to get me to 240x. And then what am I going to have to multiply the last one by?
By 240.
240 to get 240x on the bottom, right? So what do you notice about the denominator now throughout the whole thing? So what can we do with the top? Set it equal to each other, basically just solve like we did on the notes from the last time. So what is 4x minus 3x? So x equals 240 minutes. Which, if they wanted you to convert that to hours, how many hours is that? 4, isn't it? Okay. No, it's okay. I just got confused for a second too. All right, I'm gonna go ahead and hand out the homework.